The BritChips podcast is proudly sponsored by Silicon Catalyst UK. Hello, I'm Anthony Miller and welcome to the BritChips podcast, where I have conversations with movers and shakers in the UK semiconductor startup scene. My guest today studied electronic and electrical engineering at Surrey University, and in 1994 he went on to join the tech industry as a project leader in networking technology startup Madge Networks. 3 years later, in 1997, he joined Texas Instruments as a network systems engineer, but that was to last for only 1 year, because in 1998 he founded the first of two startups before eventually joining the company he now leads. He's Mark Lippett, CEO of Bristol-based semiconductor company XMOS. Mark, welcome to the BritChips podcast.
Well, thanks for the intro, Anthony, and thank you for having me.
You're very, very welcome. Now, Mark, you started your career, as I said, as an engineer. You then founded two startups of your own, and then you gave that up to join someone else's startup. Can you just take us through how all that came about?
Yeah, I guess my journey with startups actually started with Madge Networks, which was doing extremely well at the time in networking. So, and towards the end of that journey, when the company had fallen on more difficult times, and we looked quite seriously at spinning out part of the technology that we were working on there. And I really got bitten by the bug at Madge by the idea that you could actually start companies. And I actually moved to Texas Instruments. I was working in the south of France, which was kind of a lifestyle choice, but a great company. But I got the opportunity, as you say, to do something a little bit more entrepreneurial, initially in a services type context, working for Bell Labs in New Jersey and Ascot in the UK, which enabled me to build up a bit of a sort of financial buffer to start a product business, which was the second one of those two startups. The first one actually also included a web-based business. I was exploring some other options there, but my true love has always really been the interface between hardware and software, and you know what in the hardware makes software tick, and which aspects of the hardware software engineers can leverage, can gain value from, and how you can optimize that interface. And that was
Which was that startup? Because I got the two names, Silicon Formations and Igneous.
Yeah.
And which one do you refer to?
Igneous was the Silicon Formations was the company that was essentially a services organization that worked primarily on behalf of Bell Labs, Lucid Micro.
Okay.
Igneous was my first product company, and there's a certain amount of wisdom in the name. It was intended to sort of harden operating systems.
Igneous, as in wood. Yeah.
So we would put silicon IP onto the SoC itself in order to orchestrate the
SoC, system on a chip. Sorry for that.
System on chip. Yeah, my apologies. There'll be more three-letter acronyms.
Lots more where those came from.
So yeah, the thesis of that business was to make chips more efficient in terms of their operational sort of computational performance, but also the use of power, taking into account cache effect and so on. So it was a sort of almost a cross a combination of my experience in networking and managing packets transferred across into managing computational workloads or threads in the context of a system on chip. So really, and the goal of which was to make system on chip heterogeneous multi-core system on chip architecture is much more efficient than they otherwise would be. And we sold that company.
And did you succeed in that?
Yes, we did. I think it was a bit ahead of its time. It was one of those technologies that multi-core has been, well, I think it's been with us for many, many years, but actually having multiple sort of relatively equivalent computational engines in the same system on chip is somewhat newer, and that technology was really targeted towards that kind of problem. We've seen similar approaches from over the years from the likes of Intel, much later than Igneous, some sort of 5 or 10 years later. So the concept, I think, has been completely validated at the time commercially. We did license the technology. We did manage to sell the company, but it wasn't a huge commercial success. And it was actually I had a lovely summer in I think it was 2006, where I was just winding that process down. And then the CEO of XMOS, James Foster, got in touch with me, and he was a contact from the Lucent days. And he said, "Hey, why don't you come and have a look at what we're doing, what we're building down here in Bristol, and see if it's interesting to you." And I mean, the XMOS, the XMOS technology is all about hardware and software and how they interact in order to create value, and specifically create valuable system on chip solutions. It felt like it was built for, it felt like it was built for me. It was certainly right in my sort of wheelhouse from an interest perspective. So I joined the company as VP of engineering.
Because that was literally 1 year after the founders, James and the other founders, had put the company together, basically. I mean, at that time, what did XMOS think it wanted to be? What was the dream when you joined them?
So I think the dream has always been to give software engineers some of the power that previously has only really been wielded by hardware engineers, and more specifically, to give them the capability of creating hardware-like behavior on their designs that otherwise would have been requiring of dedicated chips or field programmable gate arrays, both of which are quite inaccessible in different ways. Custom ASICs are very, very expensive and very time consuming to produce, and FPGAs, particularly at the time, were becoming more and more complex, more expensive, and more power hungry, because they were chasing communications as a market, and that was demanding of a different class of chip to the area that we were focusing on, which was more in the embedded space, where flexibility was very constrained because of the economical pressures on people developing systems, embedded systems that might surround us in our houses and cars and cities and so on. The economical constraints are quite
sorry to break it. And this was based on the research that was being done at Bristol University before XMOS spun out. This is what was it? Ali was his name was working
Ali
on?
Dixon. Yeah. So Ali was working with Professor David May, who was running the computer science department.
Indeed,
who's the CTO of XMOS.
Who I've done a podcast with, an amazing gentleman. But sorry to interrupt.
A remarkable man. Yeah.
Yeah.
So he had this idea of a processor that had, obviously it had many of the attributes of any normal processor, instruction sets and compiler, C compilers and software targetability and so on. But it also had bulletproof real-time performance. So the sort of performance from a throughput perspective and from a deterministic perspective that enabled you to emulate hardware using an instruction set. So it was that sort of innovation, which is partly about what you add to the architecture and also partly about what you don't add, which gives you that level of performance that allows you to provide hardware behavior, but through a software development flow. And that realizes the vision, because then you can take one of these chips, that is application agnostic when you take it out of the tray, if you will, download your software to it, and you can create effectively your own system on chip through that mechanism. Now that
really was the dream. That really was the dream, wasn't it? To be able to get to, I mean, when you joined, after year one, I mean, how many were you? Was it just the 5 founders and you? Or?
I was actually employee number 6, and still am. I mean, in the intervening period, people have come and gone. Actually, quite a number of employees have left XMOS and come back over the years. It's quite a tight-knit ecosystem here in Bristol.
I mean, we'll come back to where you are now as we follow the journey, because a few years later, I think it was in 2012, you ascended to the COO role. What kind of prompted that? Was there a change in direction in XMOS? What prompted your promotion?
I think at that time we were contemplating AI and what it meant for our product roadmap. and we took on a new CTO, Simon Knowles, and Nigel was in charge. Nigel Toon was in charge of the business.
Right.
And we were, as I say, we were contemplating how AI would work within the XCore roadmap. XCore being the XMOS product.
Right.
And it became quite clear that actually the opportunity for AI at that time, and we're talking about, well,
10 years ago.
13 years ago,
Yeah. Or more. Yeah.
it was really on the server side,
Or 13. Yeah.
and that the characteristics of that market and the maturity of our technology in that context warranted a different business. So I think there was a sort of a period during which the company was still united, but was becoming separated. And ultimately, of course, by 2016, that became the case. GraphCore spun off of XMOS,
Right.
and that's the point at which I became chief executive. But for a couple of years prior to that, I was essentially taking a more, I guess, general management kind of role of the XMOS side of the business as we nurtured the GraphCore business.
And had the vision changed? Had the dream changed at the time that you became CEO, or are you pushing, or how far along were you?
Well, so from a revenue perspective, I think we were in the sort of low single digit kind of numbers, millions of dollars. We had established a position in audio, in specifically in USB audio, primarily in what I would call audio interfacing. And we were building our loyal customer base in that area. And it was a particularly appropriate area for us because we delivered an appropriate amount of computational performance. The price was right, and the latency performance and flexibility that our platform delivers resonated really well with that market. It's a market that's really very very particular about latency, and also really values the ability to provide a wide variety of solutions to its customer base. And we were able to capture that market. We were in competition with Cypress at the time, PSOC, another flexible technology to provide USB audio solutions, and that market has since become ours. And we've essentially used that as a beachhead to grow the business from that point. And
Because
we're now.
yeah, sorry, I can say, because it sounds like you set out, and indeed you created, a high performance, low latency chip with multiple purposes. But was it then you said, okay, now we think audio is the best application for this? I mean, there must have been lots of other use cases because, by definition, that's what you're trying to create. I mean, what particularly
Yeah.
brought XMOS into the audio spectrum, so to speak?
I think, to be honest, when you've got a new technology, you're looking for market discontinuities and as entry points to the sort of commercial world. We had a fantastic platform. It did what it said on the tin. It was incredibly deterministic. Its computational performance was very strong for the price point. But we needed to direct our commercial resources because at that point I think we had one salesperson. So we couldn't go after multiple markets. We had to pick one market and specifically one problem to solve, and that's what we did. It was the conversion of Apple from using FireWire to for audio transport to USB audio 2 that was the discontinuity that we were looking for. And we managed to effectively drink our own Kool-Aid for a period. We built a reference design based on USB Audio 2 that allowed the Apple audio ecosystem to continue to build, products based on USB, whereas they'd previously been using FireWire. And after that point, once we'd solved that problem for them, the problem of the backhaul interface changing, we were then able to convince them of the benefits of the flexibility and the latency that we deliver, low latency that we deliver. So, we've retained that customer base, and they've been very loyal to us. We've been very happy to continue to serve them with increasing levels of performance and different computational features and interfaces and so on.
So your primary customer base then was the audio interface manufacturers. Where were they based? Was it all UK, or did you have international
No,
clients?
there are customers in the UK. In fact, they're everywhere. The audio business is the audio. I have to correct myself. This part of the audio market is very diversified, and you know, super people, really passionate about audio, really passionate about their products. They're everywhere. You know, you'll find audio files all over the world. It happens that some of our biggest, are in the UK. We've got other very large customers in Europe, increasingly in Asia Pacific, and also North America, of course. And we're just discovering that there's an appetite for audio innovation in South America. So this market continues to grow as we grow our sort of geographical footprint.
Are you able to give names to any of your sort of key or reference clients? I would understand if it's confidential, but I must
I
ask.
I, I I should be circumspect about that, but
Okay.
let's say, yeah, I mean, if you look at some of the biggest audio connectivity customers, companies in the world, we're serving, I suspect, all of them.
Oh, right.
There's the XMOS solution has become quite ubiquitous and a stamp of quality as well. We've actually got customers for many years. We've had customers put our logo on the outside of their packaging. We've now got customers that are putting our logo on the product itself.
It's sort of like an Intel inside, but it's XMOS or X-Core inside. How do you brand it?
It's XMOS powered.
XMOS powered.
So
Okay.
yeah, and that's dragging more customers towards us as well. So I mean, we've expanded our market footprint significantly since then, but we're not leaving that market behind at all. We continue to invest in value-adding features for those customers.
So if you're spreading beyond that, what are you spreading into?
Well, so the path that we've taken is, I mean, a classic kind of beachhead strategy. We started out with USB audio primarily from a connectivity standpoint. We then started to add DSP features onto the platform so that we could do some
Digital signal processing, is that? Thank
Thank
you.
you. Yeah. Um,
I got my dictionary here.
Yeah, I was going to say that's the second time you've caught me out. And then we started to add signal processing, so signal conditioning, which might range from anything from reverb, which is making your voice or sound very full,
Echoey. Yeah.
or equalization to boost parts of the spectrum, anything of that nature. That was becoming part of these kinds of systems, and in fact, other systems that were adjacent. And more recently, also moving forward, we did eventually add an AI capability to our third generation, which is called X-Core AI or X-Core 300, to enable us to embed models that compact models that deliver specific value-adding features. So, for example,
this is very much still in the DSP area. It's still audio processing, basically.
I'm still at that point on the path. I'll move on in just a minute and start talking about
okay.
imaging. So at this point, we're doing things like denoising, acoustic event detection, anything that we're combining essentially signal processing, where that is the reference solution, with artificial intelligence solutions where that makes the most sense on a sort of a block by block basis. And one of the beautiful things about the X-Core architecture is you can pretty much mix and match the best in class solution, be it based on signal processing or AI or whatever, in the pipeline without restructuring your code. So I guess that sort of that's a waypoint on the audio path, if you like. We did add
just before
hmm.
you leave that, Mark. You did mention about AI and using different now incorporating different models. Are these kind of off the shelf models that you incorporate, or does XMOS develop its own models for its products?
We do not. No, we use third party partners are really important to us as a business, in every aspect actually, and none more so than in the AI space, just because of the sheer diversity of different types of models. It might be in these kinds of systems, and the models tend to be highly focused. So even if you look at something like a fan controller, there'll be many, many different languages, dialects, and so on that we would need to support in a dictionary in order to provide that solution. So what we do is, or what our mission is to be an excellent platform, an excellent target platform for other people's AI models. And that's been a very successful strategy for us.
Right. Okay, so now moving on to
So next
the
step,
next point in
right?
the journey.
So on the third generation, we started to extend our ambition into image AI. So just to sort of recap, we've gone from audio DSP to audio AI. We'd actually also, as an adjacency, done a lot of work in voice processing, voice signal processing, and voice AI. And we wanted to extend into. We saw customer opportunities where there was an appetite for some level of image AI. So with our third generation, we actually included a MIPI interface, so we could interface to low-cost images, and this allows us to take in images and do some processing on them, like for example, human presence detection, face detection, and things of that nature, and that gives us the ability to combine voice and imaging into a solution, for example, like an access control solution, where both of those modalities are needed in order to complete the picture.
Well, because I was going to ask you, I mean, there's now any number of startups who are very much into the imaging and image recognition and all, and wrapping AI around it. It must be a highly competitive market. And I was going to ask you, how can you compete in that when it sounds like that was not your initial market? I was going to say late in the game. That may be a bit unfair, but you were later than others in developing image recognition and AI. But are you saying then that somehow you kind of combine this in some way with the audio processing audio processing side?
So we're in the embedded space, and one of the sort of mantras that I trot out from time to time is that if you're not integrating, you're being integrated, right? So the question is, what is on a customer system? Our classic sort of engagement from an XMOS perspective is, we'll be introduced to an opportunity because we may have an alternative to an existing piece of silicon. And our strategy is, okay, so yes, we can replace that piece of silicon, but let's zoom out. Let's have a look at your entire system and see what we can do for you at a system level. Because it's our ambition to deliver system level economies, and to get people to market quicker than anyone else. So what we're doing is we're taking multiple features that may have required multiple chips and integrating them together on a single platform with a single development flow faster than anyone else. So
And at the moment, that's image recognition and sound processing.
Well, and many applications require both, or one or the other, or both. There may be accelerometers on there. There may be other types of sensors that require processing on that platform in order to build an agentive system or a physical system. And obviously there's the actuation side as well, which we haven't talked about. All of those things they require system level attention, but in our case, they don't require a chip to do them. So, by bringing all those features onto the same silicon, we're able to deliver very economical solutions.
But what I think you're saying is that your X-core chip, your silicon, can be programmed to do all these different things. It can do because the thing that it begs the question is there a risk that you're trying to develop this something which is going to be, the proverbial jack of all trades, but it's going to be master of none? I mean, are you chasing each opportunity? You're saying, well, let's have a look at what they're doing and see if we can do it better, or what degree of focus can you bring to the opportunities that you're chasing, so that XMOS is known, for doing, I guess, a small number of things really, really well, rather than, let's look at XMOS and see if they can do this better.
Yeah. So, I mean, the thing that we tend to focus on is low latency processing. So flexibility and low latency processing. They're actually two sides of the same coin. But you know, we're and this is primarily in order to, as you say, to focus. The challenge with XMOS is that the total available market for our platform, for our silicon platform, is vast. But we need to be very focused in terms of our go-to-market strategy in order
Exactly.
to provide enough of a solution that our customers can recognize the value that we're adding and become, you know, committed to using our solution. So that's partly about tools. It's partly about reference designs. It's partly about, you know, demonstrations of proof of concepts. All of those things that require, you know, that you become somewhat blinkered to all of the opportunities that you could go after in order to make sure that you close, you know, a smaller subset of the market. It's really just about scale. If we had more scale, we would be able to address more opportunities. But as a smaller, relatively small business, we're very focused on a subset of what we could achieve as a larger company.
Well, you hit really the core point. I feel the thing that kind of mystifies me a bit because, you know, XMOS has been around for 20 years. It is still very modest in size, as you say, both particularly in terms of revenues. You know, you've got the XMOS brand on kit now. It's really two questions. Why isn't XMOS more successful than it is, more visible than it is, more well known that it is? And what do you have to do to make it more so? I mean, you know, what do you have to do to double its size, 5 times the size, 10 times the size? You said the market is enormous.
Yeah.
You know, it sounds like you've got the chip that can almost do anything. I tell you, I was just looking at your website just before, and on the homepage it says XMOS is a semiconductor company that enables people to build anything. Build anything. You know,
Hmm.
so I can understand the opportunity. What do you have to do to chase it, to grow?
That's a great question. I mean, you know, if you look at our, you know, the substitute technologies, the technologies that we typically replace in a customer system, you're looking at primarily at microcontrollers and ARM-based SoCs, more sort of the higher end performance of Cortex kind of M series embedded processors, and that's our customers' context. So that defines their ease of use, if you like, is the familiarity they have with those kinds of platforms. And one of the things that is a real challenge about growing a company that's based on a novel, not just a novel processor, but a novel architecture, is the education process, and that does take scale. It's very difficult to accelerate that, and that's something that you know that has built. You know, we've by engaging with customers on that sort of journey, we've built a tremendous amount of commitment, but it's not always very fast. Now, not every customer needs it. You know, not every customer. Some customers have taken our technology and deployed it in areas that you know we would never have expected.
Such
But
as,
you know, all sorts of things. I mean, robotics is the thing that immediately springs to mind. We've got you know, nothing to do with audio, more on the sort of still using the real time attributes of the platform, but using it to a completely different end. So you know, in more on the sort of actuation side. So that's been, you know, we've our mantra from a tools perspective was to build tools that were as familiar as possible. Fundamentally, we needed to teach our customers about a new type of architecture, and that takes time. Now, we in the, you know, if I wind the clock right forward to sort of a year ago, two things have happened. Number one, we have our fourth generation platform now in the lab, which is the based on RISC-V. So that's torn down one of the perceived barriers, which was that XMOS had its own proprietary instruction set, which was perceived as a disadvantage. And the other barrier is on the tool side, with the generative SOC tools that we're developing now. We're able to lift the abstraction, the design abstraction, above the platform, so that our customers can talk about, you know, they can use natural language to describe applications. We can generate application level block diagrams, and we can deploy them on the chip using the performance benefits of the platform without our customers needing to know how we achieve it. So it's essentially not just a game changer for XMOS. It's actually a game changer for embedded design in general, because with this sort of generative tools, you can do all of your design in the application domain using the language of the application, and using GenSoc chips, which is the branding that we're using for XCore. You're able to guarantee its functional and timing performance as well. So you can literally design something in moments and take it to scale. We've our mantra as a business, if I wind the clock back 10 years, was let's go, let's take the embedded design process from years down to months. We're now, months down to minutes, to create a working system.
Now, the audience won't know this, but I've actually seen a demonstration of GenSoc. I did, for the benefit of the audience, go to your XMOS offices several months ago, and Mark, you gave a simple demonstration of GenSoc, which I will say did knock my socks off. It was quite incredible how easy it was to generate sort of specific function. I will come back to that. I just want to come back to this thing about RISC-V. Now, I'm not a semis guy, but you said that you've moved to the RISC-V architecture. Does that in any way compromise the performance and the latency of your chips?
That's a good question. So RISC-V is a standard instruction set, but it doesn't dictate the architecture. So we were able to effectively use the RISC-V instruction encodings and graft them onto our existing architecture. Right. So architecturally, if I were to show you a block diagram of the XCore 300 and XCore, which is based on the XMOS instruction set, and the XCore 400, which is based on RISC-V, you'd barely know the difference. So we've not given away any of the architectural attributes. What we have gained is an industry standard instruction set, and obviously quite a bit of benefit from pre-existing software, both on the tools and the application side.
And then the GenSoc layer, that sits on top of that so that customers can use it's almost like ChatGPT style interface to generate and configure a chip that has now using the RISC-V instruction set on the XCore architecture, if I've got that right. You've got
That's
the
right.
path all the way down.
Yeah, so the generative tools, as you say, they sit on top of the embedded development tools that we'd already, that have been proven in the industry for many years. So really, that generative tools take on three. They have three interfaces. The first one is to the web. So the generative tools are, use unsupervised learning to learn about how systems are put together. So that's how when you say build me a karaoke machine or whatever it might be that you're building, it knows what blocks to put in that design and how to put them together.
And knows the songs as well.
Haven't built one that sings yet.
Well, there we are. That's the next phase.
Yeah, yeah. So that's the one interface. The second interface is to our pre-existing, pre-verified, characterized libraries, and the third interface is essentially an understanding of the underlying platform. So it sort of bridges the gap between an application representation and the XMOS architecture.
Right, because you said, and I completely understand this, it's really hard to dislodge sort of incumbent thinking, incumbent technology in customers, and that's true in any industry. Trying to dislodge an incumbent and say, hey, I can do this like for like but better and cheaper is an interesting argument, but it's such both an emotional but also a risk-based change to move. I can understand why that's a focus of the business, but where's the opportunity in coming in saying, okay, you've got your legacy stuff. By the way, we can do this smarter, cheaper, whatever it is. What about, let's look at what you're doing in the future, and let's design what you're doing in the future around XCore and all the goodness that comes with it. Where can you? Is that where you're focusing your business now?
Well, if we sort of pop up for a minute, so look at the kind of the mega trends, if you like, of the industry. So we remain focused on the sort of the embedded side. So
Right.
device electronics and which by the way is one of the, we used to call it the IoT. I think nowadays we're calling it agentive and physical AI.
Right, right.
It's a it describes a mass of different things. So it's a sum of niches opportunity. It's huge, but it's highly fragmented and very dynamic. So at the top level, our opportunity in the market is based on the fact that we are offering our customers the fastest route to market with the most economical solution to address that challenge, right? So we're giving people the opportunity to get into market first, to stay in market for longer, and to do so with a more economical device, which is really very compelling. So that's the sort of the top level, if you like. That's the top level vision, if you like. We started on that, on the sort of top level empowering software engineers vision. But as we sort of drill down, there's masses of opportunities still in audio. Audio is actually having a resurgence of popularity. The robotics, the sort of new wave of robotics, is driving voice interfaces. The superior backend voice processing, conversational AI backends that we have these days are igniting a renewed interest in voice interfaces on appliances and controls and so on. Even an audio is now, electric vehicles are driving. The cabin is now an extension of your living room, and people are demanding of similar audio experiences. Gaming is becoming extremely important. Gamers are obsessive about latency because it directly correlates with their ability to win.
Yes.
All of those things, they're driving audio. Audio is a very, very large opportunity for us. But at the same time, so is, we're also getting involved in things like predictive maintenance, in networking applications, all sorts of different areas. But again, we're being disciplined about our execution. We're making sure that we can excel in the markets that we choose to enter. And so we're still, we're staying very, very laser focused. But you'll start to see XMOS diversify more in terms of our the data that we're processing. It's going to move beyond audio. I say beyond audio. It's going to extend beyond audio,
yeah.
Including imaging and other time series style problems, from other
Over
sensors.
over what sort of time frame do you want to do that?
It's happening now. It's happening now.
I mean,
sorry,
carry on, please. Yeah.
So I was just going to say the other perspective on this, which we haven't really talked about, is actuation. Is directly driving actuators, things like motors and so on. Those types of things. Once you've in an agentive AI or a physical AI system, once you've finished all the sensing and the inference, typically there's an action associated with it. It might be a sound, but in many systems it's the control of a motor, for example. So those, that's all part of our ongoing sort of integration story.
Because it sounds like you're chasing, several different opportunity areas here. I was nearly going to say chasing several dreams, which is that there may be an element of that. But the thing is, in order to do that, you need the dosh. Come to the sensitive subject of how to make money, because when I looked at your last accounts, which were 2024. XMOS revenues were $10-11 million. Why, by the way, do you report in dollars? You're a good British company.
We operate in dollars. Most of the sort of operational aspects of our business are conducted overseas.
Okay.
Yeah, we operate in dollars.
Okay, I thought I'd throw that one in, but unfortunately, also you'd lost I don't know, $5 million or something, and I believe for most of its 20-year life, XMOS has, shall we say, relied on the kindness of strangers. In other words, has been funded, taken external funding, and it sounds like the ambitions you've got to drive into these, to expand your market, to expand the applications, is going to need considerable investment. So, at what point do you think XMOS is going to be able to feed itself? And that you don't have to go out, I was going to say cap in hand almost, to say, okay, to go to the next stage.
So we were feeding ourselves a couple of years before 2024. We had it was as for many companies, particularly companies that are involved in the in those sort of device side of the business. Many companies had a good time, ironically, through a very sort of challenging period during COVID.
Yeah.
But as a small business, we were challenged because we during that period we struggled to get hold of supply.
Oh, yeah.
And then all of a sudden we had an inventory overhang, and many of our customers reset their own businesses, and so it's been a wild ride, actually, the last 3 or 4 years. I don't think representative of the underlying opportunity by any means. Despite that, I think we've nearly sold 40 million units now over the years.
Really? 40 million?
Yeah, yeah. The company's earned 150 odd, 140, $150 million of revenue over the years. So, and we're accelerating. So it's I think that the opportunity for us to become profitable and so on is just around the corner. Having said that, we've also got a fantastic roadmap, and we may choose not to break the company even, or to manage ourselves, manage our R&D somewhat ahead of profitability. We have that flexibility, and it really comes down to the availability of capital.
Well, that's the point, isn't it? It only happens if you've got investors who are happy to see it through. Very patient investors. I mean, are you, you follow the path where you're suggesting that you may continue to invest ahead of revenues, do you have the commitment from your backers to fund that?
Yes, we do. I mean, it's a constant. I would say it's almost a day-to-day kind of balance. When we're planning the business, we're balanced. Obviously, we are a revenue business, so we do generate gross profit. We have extremely good margins because we deliver a lot of value. So that delivers cash into the business for us to fund our operations and R&D. And we can choose to get capital from other sources if the roadmap warrants it. And it's to some extent is dependent on the macroeconomic sort of environment as well. But it's really down to the cost of capital. If there is capital readily available, when we excite external investors about the opportunity, external financiers about the opportunity, that capital becomes less expensive to us, then it's easier to adopt, and we can make decisions about accelerating our roadmap. It's a constant balance when you're managing the business with so much innovation. Our backlog of things that we could do is very large. We always have to be very carefully considering what of those things we should do.
So it sounds like you're saying you're not expecting to raise any more funding, at least this year, 2026. Is that what you're suggesting?
Never say never.
Well, I hope if there is the need, it would be from the good news side, that there's a development that warrants it. Because as we now look to the future, and you joined a year after the company founded. There was a dream then to not quite all things to all men, but you sounds like you're getting there. I mean, look ahead 5 years, look ahead 10 years. Where would you like XMOS to be?
Oh, in 5 years' time, we can be the go-to solution for building embedded systems.
Well, that's a pretty
So, I mean,
sweeping ambition, isn't it?
I think. Well, I think the traditional way of doing things is running out of steam. I think if I mean, we've demonstrated our ability to succeed in a constrained market with a constrained set of resources. I think the generative SOC tools that we're developing are completely transformative, and it's not just because they're going to change the game for XMOS. It's not just because we're solving a familiarity problem that we've had with the customer base, an inevitable familiarity problem because we've got a differentiated product. But also, we're changing the game for the way that systems will be designed on any platform, and we have the target platform for that approach. So there's no. I was I can't remember who I was talking to, but I said we've been trying to teach people how to drive by telling them how a 4-stroke engine works. That's how we've been dealing with embedded systems designers.
Yeah.
They don't need to know that. They just need to know that the car is going to go in the direction that they drive it, and it's going to go as fast as they drive it. Those things are important. Those are the properties that they need to benefit from. They don't need to know it's an ARM architecture. They don't need to know it's a whatever. those things.
No, I understand it because I mean, it's that's a huge thing to be the go-to place for embedded systems, given that there are so many out there, and you've built now um, a chip, a design, a whole ecosystem to make it easy to do that. But I worry that we have a sort of we've built it, now they will come, because there is so much entrenched inertia in the system to stay with what they know best. You may have you may have all the technology and tools and everything in 5 years' time. What else do you think you would need to do, though? Who do you need to convince to realize that dream of being, the preferred supplier of an embedded system on a chip?
I think there's there's many answers to that question. I think so. First of all, I think the design approach using natural language as a design interface, I think is a orders of magnitude better than any other approach that's preceded it. But at the same time, you still need customers that have got innovative ideas of how to break into markets. You still need partners that can provide you with critical IP that's properly verified and characterized. So there's a definite. I'm not saying we're solving the problem for the whole ecosystem. I'm saying we're a critical enabler for a network of companies that can pull together to deliver some real value at unprecedented speed.
So that says to me, sales, marketing, partners, and you're going to have to drive each of those. The marketing to get the message out, the sales to actually do the deals, and the partners to well, it's two ways. The partners may be partners as in customers, or partners to provide the bits like your language models. Do you have plans in place to work those sort of three strands? There may be other strands as well, but those are the ones that stand out to me as being the most.
Yeah, very much so.
Oh, good.
Yeah, very much so. Yeah.
Okay. What do you think, just to end the story? What do you think that XMOS's journey, even your journey through XMOS, do you think it has anything to say about the state of the UK semiconductor industry and the semiconductor startups? What lessons do you think founders, entrepreneurs who are creating their own semiconductor startups can learn from you, can learn from XMOS?
Crikey. That's a great question. I think one of the challenges that we face in the UK is very familiar. I think we're very good at sponsoring new technologies and not quite so good at sponsoring existing technologies to scale. I think that's been
Yep.
one of our
Yep.
one of our country's real challenges. It's well known. Great minds are thinking about how to solve it, but it's not solved yet. And I think that gives, if we can solve that problem, that gives companies the opportunity to evolve, more rapidly, and with a sort of a healthier balance between availability of capital and the obligation to create profitable businesses.
I mean, is that a funding thing there? Are you saying the answer is, or part of the answer, or a significant part of the answer is more funding for scaling up, or are there skills issues? Market access?
Well, there's market access, I think, is less of probably less of a challenge by people that are in the industry. I mean, the semiconductor industry is an international industry from the word go. I mean, generally speaking, you're not getting manufacturing done in the UK. Many of your customers are not in the UK, so it's a global industry. That's a fact almost from day one. But of course, there are benefits to having localization of talent, for example, and sort of concentration of the brain trust of the business, and that requires the ability to recruit people that are talented, skilled, experienced, etc.
Yeah, attract them
in the sort of sense
them.
of
Yeah.
And I think the we're in a privileged part of the world here, and it's even as I mentioned earlier here in Bristol, sunny today. But we do have we've got 3 great universities nearby. 4 if you include Cardiff, and it's it's a really great town to grow a business in. I think UK has a way to go before it's got the sort of availability of capital and expertise to deploy it. that would compare to something like Silicon Valley, where it's just an incredibly rich mindset of very experienced entrepreneurs.
Well, let's hope that XMOS stays firmly grounded here in the UK, and I hope that in 5 years' time, if not before, we'll be speaking again about how you've actually achieved that very dream. Mark Lippett,
Wonderful.
CEO of XMOS Semiconductor, thank you very much for joining me on the BritChips podcast.
Thanks, Anthony. Absolute pleasure as always.
Thank you.